Today, we're not making lemonade. Nope. We're going to see if we can take a few totally ordinary lemons and turn them into a real working battery. Let's do this. So, here's the big question. The challenge for today. Can you actually power a light bulb using nothing more than some fruit and a few coins? You know, it's one of those classic science experiments that feels just a little bit like a magic trick. So, what do you need to pull this off? It's actually super simple stuff. You're gonna need a few lemons, some galvanized nails. That's just a fancy way of saying they're coated in zinc. A couple of copper pennies, a little bit of copper wire, and one small LED bulb. That's it. That's our entire parts list. Okay, but before we get our hands dirty, we've got to have a quick safety chat. Super important. If you're under 12, go find an adult to help you out with this. And this is the big one. When we're all done, whatever you do not eat these lemons. The metals can kind of seep into the fruit, and trust me, you don't want that. All right, with our safety briefing out of the way, it's time to build our very first power cell. Let's get into how you can turn a regular old lemon into a battery. First things first, you gotta give your lemon a good massage. Seriously, roll it on the table, press down firmly. You wanna get all those juices flowing inside? That acidic juice is our secret ingredient. It's called an electrolyte. Next, push 4 of those galvanized nails into one side. Then, flip it over, make a few small cuts on the other side, and just slide your copper pennies right in. Okay, so our first lemon battery is officially built. This is the moment of truth. Is this one little lemon gonna have enough juice, pun intended, to light up our LED? Let's find out. So, we hook up the wires and, we've got nothing. But wait, don't be disappointed. This is actually the best part of doing science. When something doesn't work, we get to be detectives and figure out why. So what's the deal? We follow the steps. We've got our lemon battery. We've got our light bulb. So why is it still dark? What piece of the puzzle are we missing here? Well, the answer comes down to one word: voltage. The easiest way to think about voltage is like electrical push. It's the force that shoves electricity through the wires. And, well, our single lemon just doesn't have enough push to get the job done. This really lays it all out. A single lemon battery? It's got low voltage, not enough push. To get this light to turn on, we need higher voltage. We need to go from a simple lemon battery to a super lemon battery. So how do we get more of that electrical push? It's simple, really. We're going to connect our lemon batteries together. It's a technique called connecting in series, and it basically lets us add all their power up. Let me show you how it's done. Okay, go ahead and line up your 3 prepped lemons. Now I want you to think about this like you're building a little power chain. You're gonna take a piece of copper wire and connect the copper pennies in the first lemon to the nails in the second lemon. Then you just do it again. Connect the copper in lemon number 2 to the nails in lemon number 3. Now, stop for a second, because this is the single most important rule in this whole experiment. You have to make absolutely certain that the pennies and the nails do not touch each other inside the lemon. If they do, you'll get what's called a short circuit, and all our work will be for nothing, so keep them separated. All right, we have built our power cells. We've chained them together in a series. We've been super careful to avoid a short circuit. All that's left now is the grand finale. It's time to make that final connection. So if you look at your setup, you should have 2 wires that aren't connected to anything yet. One wire is coming from the nails in your very first lemon, and the other is coming from the copper in your very last lemon. The wire from the nails, that's your negative side. The one from the copper, that's the positive. Now, grab your LED. See how it has one long leg and one short leg? Connect that negative wire to the short leg and the positive wire to the long leg. And look at that. We have light. It actually worked. You just took some lemons, some nails, and a few pennies and generated enough electricity to power a light bulb. How cool is that? That's some awesome science right there. But wait. What if yours didn't light up? First of all, do not panic. This happens all the time in science. It just means it's time to put on our detective hats and do a little troubleshooting. Let's run through a quick checklist. First, are all your wire connections nice and tight? A loose wire can stop everything. Second, go back and double check. Are you positive a penny isn't touching a nail inside one of those lemons? Third, did you get the LED legs right? Rem,